So in the previous lecture, we looked at revenues, costs, and profits for the perfectly competitive firm in the total revenue and total cost framework. Okay, now let's take a different look at that. And let's look at it in terms of the math, the equations, and also we'll look at it in terms of the figure 8.3 in this, where we look at the average total cost and the marginal cost framework. Okay, so the math behind the straight line total revenue function in figure 8-2 is that total revenue is just the product of price and quantity, and then the first derivative of the total revenue function, the change in total revenue divided by the change in quantity, is marginal revenue, and that is the market price. So the business firm has to take the market price as its demand curve. Okay, in this situation, the competitive business firm can sell all the product that it wants at the market price. Okay, so the competitive output profit the profit maximizing competitive output rule is that a competitive firm should produce output where the price or the marginal revenue is equal to the marginal cost. And this is just the equimarginal, an application of the equimarginal principle. Okay, and this is the rule that we derived, okay, that we worked through in the context of chapter 5. Okay, so let's look at this graphically. So here we have the cost structure of the business firm. So resulting from the cubic cost function in figure 8-3, we get this U-shaped average total cost curve. And then the J-shaped marginal cost curve, where the marginal cost curve intersects the average total cost curve at its minimum point because of the marginal average rule. Okay, so now imagine that the price that the business firm faces is P superscript E. Okay, and again, that's the demand for the business firm's product, and that's the marginal revenue of production for the business firm. So our profit maximizing decision rule says that the business firm should set output or make its production decision, Q star, where marginal revenue is equal to marginal cost. Okay, so where those two lines intersect is where the profit maximizing output level is determined. Okay, at that output level, we also have a measure of the average total cost of production. Okay, so we just draw a line from the output level up to the average total cost curve, and that is the average total cost at the profit maximizing output level. Okay, and we can determine the amount of profits that are earned in this situation by recognizing that the total profit is the product of per unit profit and output. Okay, so let's just work through these equations. So the business firm's profit equation is price times quantity, or total revenue, minus cost of production. They depend on output. Okay, if we divide both sides of this first equation by output, then on the left-hand side of the second equation, we get per unit profit. Okay, then so if profit is $100 and we produce 10 units, then the profit per unit is $10. Okay, so that's equal to revenue per unit minus cost per unit. Okay, so revenue per unit cancels out, and so average revenue, okay, is equal to price. Okay, and notice that marginal revenue is also equal to price in a competitive market structure. So marginal revenue equals average revenue in a competitive market structure. Okay, so average revenue minus average cost is also an expression for profit per unit or per unit profit. Okay, so now if you multiply both sides of the equation by output, then we have profit is equal to the product of per unit profit, price minus average total cost, times output. Okay, so graphically, okay, that tells us that the amount of profit earned is the area of the rectangle that is bordered, that has a height of price minus average total cost. Per unit profit is on the vertical axis, and then output is on the horizontal axis. Okay, so the area of a rectangle is the base, base or Q star, 0 to Q star, times the height, price minus average total cost. And so profit is that shaded in area. Okay, so in this case, since price is greater than average total cost, profit is positive. All right, so let's put this competitive output rule into action. So it was just a little math problem that illustrates how this works. So imagine the cost function for a business firm is equal to 5 plus Q star. Okay, and notice that this is not a cubic cost function, but that's okay. Okay, it's a different functional form for the cost, and the cubic functional form is nice and neat and has a lot of nice properties graphically. But there is like we worked out in chapter 5, there's some particular restrictions that must be placed on the cubic cost function, and maybe the relationship between quantity and cost is not like that in a real world business firm. Okay, so maybe for this business firm, their cost function takes this particular form, okay, where the fixed cost is equal to 5, and then the variable cost is equal to Q squared. Okay, so now if the firm sells output in a perfectly competitive market, and other firms in the industry sell output at a price of $20, so what price should the manager of this firm charge? Okay, and then based on that price, what level of output should be produced to maximize profits, and then how much profit will be earned. Okay, so since this firm has no market power, it can't charge a price higher than $20, or it's not going to sell anything in the market because its product looks just like everyone else's, then the answer to the first question is, well, this firm has to charge $20. Okay, and then the second question is how much output should be produced? Okay, so what we do is set price equal to marginal cost, and given this total cost function, we can find the marginal cost using the product rule. Okay, the first derivative of the total cost function is just equal to 2Q, okay, the exponent placed in front of quantity, and then the exponent minus 1 leads to a marginal cost of 2Q. Okay, and since 5 doesn't vary with quantity, it goes away when we talk about marginal cost. That's just the fixed cost. Okay, so equating price and marginal cost looks like this. So price is $20, marginal cost is 2Q. So solve for Q. So Q equals 20 divided by 2. So if we divide both sides by 2, we isolate Q on one side of the equation, and 20 divided by 2 is 10. So 10 units is the profit maximizing output level. Okay, and then maximum profits. Okay, so profit, we would take per unit revenue, or $20, multiply that by 10, and so total revenue is $200, and then total cost is equal to 5 plus, we'll plug in 10 into the cost function, so 10 squared is 100, so total cost is 105, so 200 minus 105 is $95. So given this cost and revenue functions, this is what the problem looks like graphically. So I took those functions, plugged them into Excel, and then drew this graph. So the total cost function with a squared term is just upward sloping, and costs are always increasing at an increasing rate. And then the total revenue function, it's a ray from the origin with a slope of 20, because that's the price. Okay, and it's this upward sloping orange line indicated by rectangles. And the total cost function is blue if you're good with color, and it's indicated by circles. So you can see, as long as the total revenue line, the straight line, is above the total cost line, the business firm is earning profits, earning positive economic profits. Okay, but if you just squint, you can see that at an output level of 10, the distance between the total revenue and the total cost line are equal. Okay, and those equal, the distance between the total revenue and the total cost line is maximized. And that's because a line drawn tangent to the total cost line is parallel with the total revenue function. Okay, and all that's easier to see when we convert total cost to average total cost and total revenue to average revenue, or price, or marginal revenue. All those three terms are synonymous for a business firm that operates in a competitive market. So here's what that picture looks like. Again, the cost function, the cost curve, is blue with dots. The revenue, average revenue, marginal revenue, price line is orange with squares. And now I've drawn the marginal cost, which is equal to 2 times Q. So that is a ray from the origin in this diagram. Okay, so that's the green line indicated by triangles. Okay, and you can see that price is equal to marginal cost at an output level of 10. And so that is greater than the average total cost, which is equal to around 10. It's actually 10.5. And so profit can be determined by the rectangle bordered at the top by the price line up to 10, and then down, and then across.